Okay, so this is part 3 of exercise 3 in chapter 2 of the Advanced GIS book. In this video, we're going to look at producing aspect maps in the surface tools within ArcGIS Pro and explore the option of a 3-color aspect with slope shade image as an alternative to hillshade imagery. I will say that producing an aspect map is more intensive processing-wise than the hillshade or slope shade maps that we've produced so far. And that's because aspect has to first kind of calculate what is the slope as a part of that. And so it's more of it's a multi-step process, has even more processing involved. So if you're doing it for LiDAR, it's going to take a long time if you do it over the whole data set. And if you're going to use it for a visualization tool like I'm talking about, it's best done for like low relief areas, like these alluvial fans and things. So you might not want to process the whole data set, and I'll show you how to do it in a slightly different way. So to produce an aspect map, it's within surface as well, or surface parameter tools as the other ones are good. So all of these are derivatives of the actual DEM, and so aspect is, I'll just go with the defaults. But here now I'm going to change the extent. So I just want to produce this over the area that we're looking at right now, so this runs faster. So that would just, which one of those is these? The extent, X and Y extent is current display extent, this little symbol right here. And so it's only going to do it over the visual window, okay? And so I'm going to go ahead and run that. It's doing it on the LiDAR, aspect fill, aspect of LiDAR at Bicknell. Just to be clear, it's only there. So I'll run that. And so this shouldn't take too long now because we've limited the processing extent to the visible window. Great, and so this is how LiDAR typically, or sorry, aspects typically comes, right? It's classified as flat, so like basically horizontal surface. I don't see any of those here, or different directionals. And it's 1, 2, 3, 4, 9 directions, right? North, northeast, east, southeast, south, southwest, west, northwest, and north again. And so, yeah, that is how it typically comes in terms of symbology. And that can be useful. Notice again, if I zoom out, it's only available right here because of what we just processed over. But another way to go is, instead of classified, you can make a stretched aspect map. And that's a little bit funky, right? It looks weird as compared to the adjacent slope shade right above it, right? There are some differences and some commonalities. The shading is going to go with the aspect direction. And so the cool thing about that is we can really see interesting details of the alluvial fan channels there. It's like an exaggerated fan topography. You can see where channels kind of go away from each other. It's a weird, wild effect. It doesn't show very well this fault scarp, which is very different in the slope shade. But where they start to like maybe become interesting is when you merge the two through transparencies. So I'm going to make the aspect 50% transparent. And so now we're seeing the slope shade through it. And so you can see that we've added some character back to that might have been lost when we used the slope shade by by having this stretched aspect map. Does get a little funkier in the higher topography, although can't see too much of that because of how I processed it. Now, let's put on top of all that the hillshade, and let's make sure there's transparency on the hillshade. Okay, so right now we are on the aspect, stretched aspect plus slope shade. And so it's got a lot of robust character. I'm going to turn off the aspect so we can see slope shade again by itself. Now I'm going to turn on the hillshade. And so hopefully you see that there are some commonalities, right, between the hillshade and the combined effect of the other two. So now I'm going to turn off the hillshade. And so you can see then the combined effect of that stretched aspect and the slope map. And so that stretched aspect plus slope map really brings a lot of low relief topography details out. Yeah, that's that one. So I often, instead of using a hillshade these days, I use this slope plus transparent aspect. Now, I usually don't leave the aspect in a gray scale like we see here, although it does have quite the effect. Instead, what I'll do is I'll first change this to all values, no trimming, and then I'll go to a kind of color wheel almost effect where we're going between three colors, stretch three colors, plus slope shade. So this kind of natural color is fine with me. And so now we see the shading is by slope, and then color shows us direction that the slope faces, which is aspect. And so we can see that this side is facing a different direction than that. And so I tend to like this. It looks a little less exaggerated than what we saw in the just stretched of one shading of the aspect. I think this is better. This, what I call three color aspect transparent overlaid on a slip shade. And it really allows you to like see the details of the alluvial fans, channels, preserves things like fault scarps and river terrace risers really well. It does get a little weird when you get into steeper areas with kind of big contrasts in aspect, where it just kind of looks like blocks of color and blobs. And so again, like where would I use this? I'd use it in low relief areas out in the valley bottoms to look at really detailed parts of that topography. It really exaggerates things. We don't want to exaggerate the cliffs and things. That doesn't help us. Okay, so that is kind of three-colored aspect, or producing an aspect map in general, and combining it with LiDAR slope shade is quite an effect. Now we can go and turn off these and go back to our low res imagery just to practice here. We had our hillshade over the entire area. If we wanted to go back now and try to produce an aspect on the regional DEM aspect of ALOS, and we'll do it for the whole area so you can see what that's like. Oh, I forgot to change the environment. Let's go back. So careful about that. ALOS all. Okay, so there's our aspect map based on the 30-meter digital elevation model. And so what is the utility of that, you might ask? Well, great question. It is a common type of image used to kind of see what direction pixels face, and that could be used in kind of modeling flow across the landscape of water, things like that. And like I said, it can also be a visualization product in other aspects, right? If you look at different, if you look at different scales in LiDAR, it looks like a good visualization product. Aspects can also be two kind of good classified areas to look at different micro habitats or micro weather zones, right? On northeast facing slopes, we might preserve more water in the landscape in these desert climates as opposed to southwest. And so you could kind of classify different parts of the landscape and investigate the ecology in these different areas. So aspect can be quite useful for a lot of things. And if you're going to do that, you might use a low resolution data, which like this, that processes really quickly, as opposed to doing it over a LiDAR data set, which that processing time may take 30 minutes or something over this whole area. But, depends on the scale of your analysis and what you hope to accomplish. So anyways, that's part 3, producing an aspect map and exploring that 3D 3-color aspect combined with LiDAR slope shade. So let's zoom to that just a minute longer so you can see the combined effect, right, of those 3-color aspect and slope shade. Really detailed. All right, I'll stop this video here, and then we just have one more. Part 4 is creating contours from the digital elevation models.